That's what happens when you leak code for a long time. You leak code for a while, bro, you get strong. Trying to keep my arms strong. That's what happens when you leak code, bro. You get real buff. Hope everyone out there is doing well. I imagine there's going to be a little bit of an uptick on my YouTube because there's layoffs all around. That 2010 to 2021 tech bubble decided to burst these last few months, and it's a rough dog. All right, so let's go ahead and get into this easy to introduce you back to Leetcode. I'm talking to you, Lyft engineers. Uber all day. You are given an array of equal length strings words. Assumes that the length of each string is n. Each string words I can be converted into a difference integer array, difference I of length n minus 1, where difference ij equals words I j plus 1 minus words I j, where 0 is less than or equal to j minus 2. Okay, so you can basically determine, right, you can calculate this associated array from an initial list of words. So if you had ACB, that equals a new array where you have the order of C minus the order of A. And then your last index is the order of B minus the order of C. All right, so I just take this, subtract that. That's the first index. This, subtract that. That's the next index. So it's like a running subtraction from each index. So let's first create that function before we even continue this. All right, so if you did that, C, the order of C, well, that's the second letter in the alphabet, or the third letter, but if we're starting from 0, that'd be index 2. A is 0, so 2 minus 0 is 2. Then you look at this, B. B's number 1, right, because A is 0, B is 1. C is 2, so 1 minus 2, negative 1. Okay. So let's make that difference. So the difference for a word, we'll just return a tuple, which is the word at J, the order of the word at J, minus the order of the word at J minus 1. For the range, for J in range, well, we don't want to start at 0 because there's nothing for it to look at before, right? Like in this example, we don't start with A on the right side, right? Because there's nothing at the left of A to subtract. So you start at 1, and then you go to the length of the word. All right. So if we print the difference of what's given here, ACB, we should see 2, negative 1. But as a tuple, because I decided to do it as a tuple, not as an array. I thought you could do that, but I guess not. Maybe that'll force it to be a tuple. Okay. 2, negative 1. All right, so what we're going to do in this example is all the strings and words have the same difference integer array except one. You should find that string. Return the string and words that has a difference integer array. Okay, well, so we'll create this scene dict. I'm just trying to think about how we're going to do this, because what we could do is look at each word and count how many times we've seen it, and then at the end return the one that we've only seen once. But that'll have n times space complexity. That's because we're going to have to say not time complexity, yeah, n times space complexity, because we're going to have to save information for each word. So there's probably a constant way of doing this if we're smart about it. If we don't want to be smart about it, we could just say seen at the difference of word plus equal 1. So we'll make this a default dict with the default value 0. Right? And then we could look at and say, we could look at the word again, and we could say if seen at word equals 1, return word. Right, so that's an n time algorithm and n time space complexity. Oh, that's crazy. Oh, well, that's going to return the... So then we'd have to create another... No. So we'll create a word difference. Why is this problem so hard to me? It's so weird. It's supposed to be easy. Equals different at word. So if it's already in scene, there's only one that's different. So if this is already in scene, then this is not what we're looking for. So we could say found double equals true. So if the word difference is not in, if it's not in scene, so it's not in scene, but found double, but it's already found a double. So we've already found two instances of something and we haven't seen this thing yet, then this is the word, right? Because else we just add we're going to say seen at word difference plus equal 1. Oh, we don't need to do that. Oh my gosh. Trying to think about all edge cases. What if we're seeing a word, but the length of the thing is 2? So if the length of seen equals 2, then word not equal, oh my gosh, this is getting so ugly. All right, I think that should address everything. I'm gonna try this before I explain it because I'm not even sure it's right. If word not equal word difference. Okay, so how does this gonna work? So it just returns on the first thing. Oh, because return found double should be false first. Okay, so it finds one word. It says, is word difference in seen? No. If it's found a double? No. So then it says seen word difference equals word. Then it looks at Bob and say, is word difference in scene? No. Is it found double? No. So scene word difference equals words. So then it'll have Alice and Bob in there. All right. And then this one, CC. Say word difference in scene. Yes. Length of scene equals 2. Yes. For W in scene, if W not equal, return scene at W. All right, cool. So this is probably my worst video ever because I just went through it and I wrote really terrible code and I didn't explain what I was doing. There's probably a way easier way of writing this, but what's the runtime of this? Well, the reason why I made this so confusing is, well, there's really a couple cases you can encounter, right? Since there's only going to be 2 things that could be in this scene dict, or there can only be 2 things in there because there's only 2 unique word differences, right? Because all of them are going to have 1 word difference value, and then a single word will have a different word difference value. So we find the word difference and we say, well, if we've already seen this word difference, that means that we found a double. So if we see the same word difference twice, that means that the word corresponding to that word difference is not, I repeat, is not the difference word, right? Because if it's seen twice, then it isn't the one we're supposed to return, because the one we're supposed to return only occurs once. So that means we found this double. Now, if the length of scene equals 2, that means that we've already found 2 unique words, and one of them is the one that occurs twice, right? Since we're here, that means that we've seen one twice. So the one that we've seen twice is not the one we want to return. So we return the other one. Right? We return the other one because this is the one we've seen twice. If we haven't seen the word yet, but we've already found a double, that means that we've already seen the same word twice. So now the one that we're looking at is the word. Otherwise, we don't know if this is the word or if it's not the word. So we just say seen at word difference equals word so that it can be returned later. All right, so that's the answer to this. I guarantee I'm going to go on here and there's going to be a really beautiful answer. 3-line solution. Yeah, but that's not, I could have done something like that, but this is all about runtime and space-time. So the space-time of this, the worst case word, so if M is the length of a word and N is the number of words, we have to do N words because in the worst case, we have to look at every word except the last word. And for every word, we have to calculate this difference. And that takes N time. So this is NM time. Right? There's really no escaping that because if in the worst case, all the words are the same except the last one. So we have to look at every single word. And we have to find the difference for every single word with length M. So we have to do M operations N times. The reason why this solution is annoying but better is because of the space-time. Right? The space-time. The space complexity. Because we have it set that scene never is greater than 2. Right? Because when you calculate a word's difference, no matter how you set this up, scene will never be greater than 2. Well, because first there's only 2 words. If we've seen a word already and we keep seeing the same word over and over again, we never update scene, so it never grows. It's always going to get 1 element and it's going to wait for the case where there's 2 elements inside. And if there's 2 elements inside, then it's going to make a return statement, right? So then all we need then is constant space, right? Because Well, I guess this is going to return M space. So we need M space at least, right? But not even M space, just the length of one word or length of two words, but it's going to be scaling with M because we need like 3 M words at most that we're saving. But all right, even just calculating this is using space, so O of M space. All right, guys. Sorry about today's video, but I'm really busy, so I did something easy, but it turns out that the easy thing is sometimes harder than the hard thing. All right. Peace out.